A table of values, okay? And when we say table, I know what you guys think. Probably you think of, you guys, I've heard you call it a T-chart, right? Okay? So go ahead and kind of make a little T-chart. And when you make a T-chart, or your table, as we're going to call it now, you know that you're dealing with values that are X's and Y's, right? And the reason we deal with X's and Y's because we're going to start to talk about graphing on a coordinate plane. And on a coordinate plane, the axes are labeled X and Y, okay? And when to get points on that coordinate plane, we plot ordered pairs in the form of X comma Y. So that's how they're all related. All right. So right above this X and this Y, I want you to write the word input. And then above the Y, you're going to put output. Ryan, will you grab that door, please? All right. So the first thing we need to think about is I'm going to write an equation above this table. We're going to make it y equals 3x. So somewhere right above your table, and a lot of times you'll see the table, except it'll be straight. It'll be written, there'll be lines through it. You can box it off. Just make sure if you're going to draw those lines that you have 5 little boxes there. Okay. So we're going to start with a set of numbers, and we always start at 0, right? Okay? Except I want you to think of the 2 numbers that are to the left of 0, and then 2 numbers that are to the right of 0. So if 0 is right smack in the middle, we're going to go from -2, -1, 0, 1, and 2. And these are going to be the 5 numbers that we use today. So if you're kind of thinking of a number line, you're just thinking of -2, -1, 0, 1, and 2. And those are going to be our input values today. And I know what you're thinking. What do you mean input? So I'm going to ask you, has anybody ever been to the airport? We had to go through security. Okay? So there's this, it's like a grocery cart belt, right? Where you buy your groceries. And it's a belt, and it just keeps going and going, and you put the stuff on it. Okay? But at the airport, there's this little thing and when you walk through the metal detector, you have to take your watch and your rings and your belt. The guys have to take their belts off and their shoes, and they put it in this basket, and then it goes through, and then it's x-rayed, and somebody's sitting at the chair, and they look at it, right? And then it kind of spits your stuff out, and you take it, and then you are good to go, right? Okay, anybody done that? All right. So we're going to say that this is the little machine where all the stuff takes place. And this is going to be your input, meaning what you put into that little basket. So your input is going to go in this little basket. It's going to go in this little machine. And in this machine, y equals 3x is going to happen to it. You don't understand what that means yet, but you will. So we're going to put something in this basket, shoot it through here, and then something's going to happen while it's under that curtain, and then it's going to shoot something else out. And what shoots out of it is going to be called the output. Yeah. All right. So I want you to kind of picture this little machine. And I have my inputs right here. My inputs are all my x values. So what that means is I'm going to take and if you want to do this in color, you can. It might not be a bad idea. I'm just going to put my input. The first x value I have is -2. So I'm going to put a -2 into that little basket. It's going to start rolling and moving. It's going to get in here, and this is where all the magic happens, right? So if x is -2, instead of putting x, you're going to put -2, right? And when an x is right next to a number, what does that mean? Multiply, right? So what you're telling me is that the y value is going to be 3 times whatever x value you choose. So if the x value is -2, then the output or the y value is 3 times -2, which is -6. So y equals -6. I want you to just kind of look at this right here. So this box should have probably gone in there. as to show your work. So when I put in a -2, it got behind the curtain, it multiplied by a 3, and it spit out a -6. So we go up to our table, not a -6. I go up to my table, and when my input was -2, my output was -6. Did that make sense? So now I input my next one, which is going to be a -1. So now I'm going to pretend like that -2 is not there, and I'm going to input a -1. It's going to move down the tray. It's going to get in there. And this time, that 3 is not going to be multiplied by a -2, but by a -1, which then means that my output or my y is what this time? -3. So y equals -3 got spit out there. Okay? You seeing what's happening? So, yeah.
So you basically just take the number that's in the x and multiply it by the y.
Yes, that's exactly what you do. And Tara kind of just saw a little pattern here. She said, well, y equals 3x means y equals 3 times x, right? So whatever x is, you just take your input and you multiply by 3. Yeah. Okay, I was just kind of showing you because later it gets a little complicated, the work. So let's take my input, which is 0, multiply by 3. What's 0 times anything? 0. What's 1 times 3? And what's 2 times 3? So there is my input-output table. It's called a table of values in 7th and 8th grade. Probably is the terminology input-output is what you learned about in 6th grade, okay? Got it? Does that make sense so far? So when I input these numbers, I output these. So let's make another one. Another input-output table. This one will do x, y. I'm not going to put the word input-output because you already should know that there. So we'll do, this one is, and you'll see the equation up there. We'll do this one as y equals -4x. Excuse me. Thank you. So y equals -4x. Okay? Now, technically, you can choose whichever values you want for your input. You could choose 100 if you want. If you want x to be 100, you go right ahead. And then you just multiply 100 by -4, okay? I'm always just going to use a standard... So you get a couple negatives, you get a 0 and a couple positives. Those 5 are pretty standard. So let's input this and see what we get. We're not going to do the fancy machine this time. And at some point, you don't even have to show the work if you think you know what you're doing. So I'm inputting my first x value, which is -2, which is going to mean what? That my output is 8. Good. So what do I get when I input a -1 there? Meaning, just like Tara said last time, so all you do is take all these numbers and multiply them by 3. Yep. So all you do this time is take all your inputs and multiply them by -4, right? So what is -1 times -4? +4. What's 0 times anything? 0. What's 1 times -4? Be careful with your signs. And what's 2 times -4? All right. That is completing your input-output table. Okay? We're going to do one more, and then we're going to get into the markers and the rulers that you're going to be using in a minute. So let's make one more input-output table. Make your x and your y. This one we're going to make y equals x minus 2. Okay? Choosing our standard input, -2, -1, 0, 1, 2. It's literally if you're standing at 0 on a number line, like it's on the floor right there, it's the 2 numbers to the left and 2 to the right. All right, this one's a little kind of trickier because am I going to be multiplying anything? No. What this is saying is that, hey guys, all these y values are whatever the x values are times 4, -4. This one is saying, okay guys, your y value is going to be equal to whatever your x value is, except -2. So this is where it gets kind of tricky. If you're at -2, the number line on my floor right here, if I'm standing at -2, and be careful, I want to take 2 away from it, and taking away means I move to the left, where will I land? I'm at -3, now I'm at -4. So if I have -2 and I take 2 away from that, I land at -4. And here's what that looks like. Your y value is equal to -2 minus 2, which you say as -2 plus -2, right? Remember when I had you draw the lines like that? I said everything's addition, -2 plus -2. So if I'm standing at -1 and I take 2 away from it, where am I at? -3. If I'm standing at 0 and I take 2 away. Okay, at what point did you guys realize maybe that you can, did you see patterns with any of these green numbers? Yeah? Let's just finish this up and then we're going to talk about those patterns. So what would be next? Standing at 1 and I go back to -1. Now I'm standing at 2 and I go back to 0. Okay. So, do you remember when I had you writing all those X's really fast to see how many and you timed yourself? Okay. Do you remember that we kind of put it in something like this? Look like a table of values. And then what did I have you do with these numbers over here? Do you remember me saying, did anybody's go up by the same number each time? And nobody's in here is dead. Nobody in here is dead. But the previous year I had showed you an example. And that kid's went up by the same amount every time. And when he plotted all those points, it was a straight line. You got it. So, how much did this go up from -6 to -3? 3. It went up, right? Because if I'm standing at -6 by the door, to get to -3, I went to the right. So, next to, and this is where you can use your red if you want, because it does help it stand out. That to that is a +3. Then the -3 to a 0 is also a +3. And then another +3 and another one. So, do you remember me saying when these numbers are all the same, it's called a constant rate of change. And when you plot them, it's a straight line. Remember I said grab your ruler. Try to get all your points on your graph to touch the ruler. And you couldn't do it, right? Because these numbers were all different. And I told you the word linear, right? What happens here? I'm going from 8 to 4, which means I went down 4, and then I went from 4 to 0, and then down another 4, and then down another 4. Is this going to be a straight line? Constant rate of change. Find the difference here. Actually +1, +1. So all of these will be straight lines, okay? They're all going to be linear. So next, I'm going to pass out a packet to you, and we're going